Hello and welcome to this tutorial on how to do penetration testing and vulnerability scanning on a backend REST API we wrote ourselves using tools like Nuclei and Sql Map. So both tools help us in identifying vulnerabilities. Nuclei is more focused on general vulnerability scanning, whereas Sql Map is focused on SQL injection. So we're gonna see a very small REST API we wrote with some issues regarding the validation of input parameters and the way we perform SQL queries. And we're gonna see how we can take advantage of tools like, for example, SQL Map to basically pull the whole database schema out of the API. Okay, so let's briefly talk about this backend API that contains vulnerabilities. We wrote a very small, very simple backend API in Node.js. We're gonna see this in a moment, but let's just talk about the server. So this is HTTP port 3000. This is use Express.js and is very common in Node.js using this kind of library. And given that we expose this API on localhost port 3000, we can use the curl command to get the data that is behind this endpoint at the path foo safe, and also we can again use curl to get the data behind foo unsafe. And as we will see, this way of providing query parameters is can be exploited, because basically we will see we won't be validating this input, and also we will use this piece of information in the SQL code we write to retrieve the information, and this is gonna be the root of all our problems. So let's briefly check these endpoints. So here you see we define the Express API. Here we basically define our SQL. Given that this is a very simple example, when we start our SQL server, we basically drop a table in the database that is here. The connection string to the database is here. Then we create the table again. As you can see, it's just an ID column and a category column, and then we insert this row this is the one we're gonna retrieve when we perform all the vulnerability tests and the SQL injection tests. Here you see this is a very simple function to connect to a database, providing a database client. We're using this Node.js library to connect to a Postgres database, and here we instantiate as a global object our client connection, and this is the one we're gonna use in our endpoints. And here we define two endpoints. So one is a get on a foo safe path. Here you see we validate the input, which is, if we go back to our curl commands, the input is basically the URL containing the path, but also the query parameters. So we want to retrieve the row with ID equals 1. So basically, if ID is empty, or is not a number, or is not an integer, then we return 400 saying this request is not valid. However, if the ID is valid, then we perform a query on the database, but we don't build the SQL ourselves. Instead, we provide a placeholder with a $sign and 1, meaning the first parameter of the list, and then we provide all the parameters in an array or a list. So in this case, it's just the ID. So what the database client library, this one, Node Postgres, what is this library going to do? It is going to replace this placeholder with this value, and it's going to perform some checks on it, so we're sure that basically the risk of being affected by SQL injection is minimal. If for some reason the database client is returning an error, we return internal server error because we're not expecting this scenario. However, if we find the data that we're looking for, that's contained in the response, database response, and the parameter rows. So we basically print them to the standard out because this is not a real API, and we just send back that this is a safe ID retrieval with the value of the ID that we validated. Okay, so in case we want to use an unsafe endpoint, we basically don't care about validating at all input parameters, and then not only we don't validate input parameters, but we also perform a query, a SQL query that we build ourselves. So rather than allowing the client, database client, to inject the parameters in the SQL query, we do it ourselves. And because of SQL injection attacks and because of the way SQL works, this ID could actually be a very long SQL string that allows the attacker to pull the entire database. So we will see that eventually we will be able to pull the definition of this table and also all the rows, all the data contained in this table. So this is a very serious attack. Okay, briefly we've seen this before, but basically this is the way we instantiate an instance of the server listening on port 3000. Because we want to avoid leaking sockets, leaving TCP sockets open whenever we shut down this application, like for example with sigterm as a signal or sigint when we press Ctrl+C, we also want to stop the application, which means basically stopping the database connection that is instantiated as DB client. Okay, so let's briefly see this in action. I have already started my application with make run, which from the make file is gonna install the dependencies and then run the application. You can briefly see also the package.json file, and here you see that the script node run up is basically npm run up is basically invoking node and index.js. So it's gonna run this code. So when we install all the packages and invoke npm run up, we get our server up and running that is printing this. We see it here as a console log, and also because we want to create tables, drop tables, create tables, and insert some data in our tables as a first step. Here we also do that with DB client query and then the query we prepared in the beginning, and then so we see this information that basically is saying we just performed 3 operations. Okay, so if we go back to our make file, you see we can get both from the safe endpoint and from the unsafe endpoint. This is nothing fancy, we're gonna do it again here, but basically we can do make http get unsafe, and you see we get unsafe ID passed 1, and this is coming from the database. And then we can do make http get safe, and this is returning safe ID 1, and again this is coming from the database. Alright, so we can start doing some penetration testing. Let's briefly see this markdown. We're gonna use 2 different tools, Nuclei and Sql Map. We need to have this application up and running, and then we can start bombarding the endpoints of this application with lots of requests to see what is able to penetrate. I've already run this because it's taking a very long while, but all the code is on GitHub, so I encourage you to go there, clone the code, and test this yourself. Regarding Nuclei, the documentation is a good starting point. We basically install our application with Nuclei install. I have a Go development environment in my laptop, so I decided to go with the installation via Go Get, but there's also a binary provided by Project Discovery, so you can potentially install directly the binary rather than using Go to install this project. And then you need to install the standard templates. This is a very long list full of very different tests that are provided as YAML configuration files that describe an attack. You can also write your own templates if you want to test some very specific scenarios, but we can start from this collection of tests. And then you can run Nuclei this way. You can print some stats in the logs. This is a rate limit limiting the number of concurrent requests you perform attacking your application server. Here we provide the list of URLs to attack, and if we check this file that is in our sample sample backend REST app, the Node.js app, you see we basically attack the root of our application server and then the safe path and the unsafe path. So with Nuclei, if we check the logs, we will see we're not finding anything super dangerous. It's all about HTTP headers that are missing, and then allow the Nuclei to get a bit of information about the API. For example, you see access control, allow origin, these kind of things. I encourage you to go ahead and read about these issues, but with Nuclei we're not able to pull that much information from the API. However, if we move to Sql Map, and again this is open source code, this Sql Map, the information is all about in their official website. This is a Python Python script that could be installed with pip, so the package manager for Python. So here you can see how you can install Sql Map in your environment, and then you just invoke it from the command line, like Sql Map version, to check the version. And here you can see, well, we remove some directories containing analysis from previous attacks. Also there's this temporary folder, some files that Sql Map produces, but then the command is actually this one. So if you check the documentation here, you will see Sql Map is very flexible, so you can invoke it in many different ways, targeting many different scenarios. What we do here is that because we make some sort of educated guess that our database is a Postgres database, we already set this as a command line parameter to our Sql Map command. So this allows Sql Map to be able to be much faster, rather than checking, for example, attacks for MySQL or SQL Server or any kind of database. And a very interesting thing is that after running Sql Map, and by the way, with this level and this risk value, this is taking around 10 to 20 minutes depending on your laptop to target our application. So I've already run this, and I'm already showing now all the output logs. But basically, the very interesting thing of invoking this command targeting localhost 3000, because you see we are specifying the URLs to scan that we've seen before, so the safe path and the unsafe path. The very interesting thing is that in our logs we see already the SQL Map Logs, the structure of this database, you see, is pulling the entire table that we are creating at the beginning in your application server. You see, is pulling this table in its entirety, so all the rows like values 1 full cat, value 1 full cat, and it also is able to understand, of course, that this is a Postgres SQL, but this is because if we go back to our command, we specify that this is a Postgres SQL, but it's the only, let's say, educated guess that we make. But then it's also able to see that this is running on Alpine Linux, and this is because I'm running this as a Docker container. You can check the code when on the GitHub repository, and also it's able to know that this is an Express application. Here you see we are requiring Express as a dependency. In our package.json you see we have Express as a dependency. So it's very important to run these kind of penetration tests against your backend APIs. If you are developers, you should be familiar with validating input parameters where they come in, and also using the database connection to allow them to inject parameters rather than injecting them yourself. So if you're adopting this kind of best practice, you're able to minimize the risk to be attacked with a SQL injection attack. Okay, so that's it for today. I hope you enjoyed this overview of vulnerability scanning and SQL injection tools that you could use yourself to make your backend APIs more secure. Happy penetration testing to everyone, and I will catch you on the next one.